So previously we've been talking about one-dimensional and two-dimensional arrays as a means of storing or representing abstract data types. So for example, we used one-dimensional arrays for stacks and queues in previous videos. But you've got to start thinking about how these values are stored in memory. It's not always as an array in a linear list. Okay, sometimes the list items are stored in different parts of memory. And each part of the array contains an identifier that tells the computer where the next part of the array is stored, or the next part of the data structure is stored. And this is called a linked list. Now each element of the list, which I've just consider these little boxes for a second. These are called nodes. Now nodes contain a number of things. It contains one or many data items and also a pointer, which is the variable that stores the address of the next node in the linked list. And if we think about how linked lists work, each node contains its data item or data items, and it has a pointer which links to the next node which has data items, and a pointer which links to the next node, and so on until it gets to the end. How can you determine the end of a linked list? Well, you have something which is called a null pointer, which I'm just going to draw in here. And a null pointer is just a 0 with a line through it. And that tells the processor, or the program that's processing the linked list, that it's reached the end of the linked list. But how do we determine where the start of a linked list is? If we don't have a node, if we don't know where the node is, we don't know where the start of the list is. So instead of having a node with a data item or items and a pointer, we just have a pointer. And this pointer just contains the location of the first node in the linked list. We call this pointer, or this value, the start pointer, just as we call the end of the linked list a null pointer. If we look at this sample question, I'll show you the difference between normal traversal of an array, a one-dimensional array, and traversal of a linked list. So if we start with normal traversal of an array, this is this section here, where it says state the value of the following surname list element 4 dot surname. So if this is a two-dimensional array or a object, surname list element 4, okay, dot surname will give us woo. But with the pointer, you have to follow the start pointer, which is 3. So that points to the first element in the linked list, which is Chan. Okay, if we're getting the surname. And then we have to follow the next pointer to the next element in the linked list, which is element 6. And then that pointer will point to the third element in the list. This pointer will point to the fourth element in the list, and then the fifth, and finally the sixth. And then you can see that element 5 has got a null pointer. So we don't traverse it in the same way as a one-dimensional array, sequentially from left to right. We follow the pointers. So if we look at the second question here, it's only worth 1 mark. But if we had to state the value of surname list start pointer dot pointer, it would be 6. When you're creating a linked list in pseudocode, you have to start off by declaring a user-defined type that can hold information about each node in the linked list. So this user-defined data structure is called LST node, so short for list node, and it contains one data item, which is a character, and it also contains a pointer, which is an integer value that tells you where the next node in the linked list is held. So to make sure that we can use this user-defined data type, we have to create an array, because we're still going to use a one-dimensional array. Use a one-dimensional array of LST node. So the first thing to point out is that we're creating an array called mylist, which has 10 elements, starting at 0, finishing at 9, and each element in the array contains a list node. So each element of the array has a data item and a pointer. We need a start pointer, which is going to hold an integer value, telling us which of the 10 possible elements of the array is a start pointer. And we have something which is a constant, because it's not going to change, which is the null pointer. Now, as you would have seen on previous slides, we used 0 to identify the null pointer, but because we have array element 0, we can't use a 0, so we have to use a -1. You can get around this by starting your array at 1, so 1 to 10 for example, and then you can have null pointer being 0. But in this instance, I've decided to make a null pointer -1. The last thing we need is this variable called free pointer, and this is useful because it holds the position in the array of the next empty list node. And so once we've declared all the variables that we need to use in our linked list, we need to set them up, we need to initialize them. So I'm going to make a procedure called Initialize List, and I'll try and squeeze it in at the bottom of this page. So the first thing we do is we initialize the value of start pointer, because it's an empty list, to the null pointer position, which is -1. And then we set the free pointer to the first available position in the array of mylist. Okay, so because we're initializing it, it'll be the first element that's available in the array, which in this case is 0. Okay, which is why null pointer is -1 instead of 0. I'm going to draw it in blue up here, just so you can visualize the list. So this is the array. We see it from left to right, array element 0 up to 9. But inside each array there is an object which is a list node, and it's got a data item and a pointer. And so next we loop around all the elements in the array from 0 to 9, and we set that current array element pointer to be whatever index is plus 1. And so we end up with numbers along here that point to the next element in the array. At this point, the last element will have an invalid pointer, but we're going to change that in just a second. And so this final line here takes the element, or the pointer, from element 9 in the array and changes it from 10, which is currently an invalid pointer, to the null pointer, which was set as -1. And that's our linked list set up and ready to perform some operations on.